All right, I think let's get started. Again, welcome to everyone to our third calcbond webinar today about the material cards. I'm Axel, and next to me is Fabian.
Hello.
So first of all, I have a few announcements. So please keep your microphones muted and your camera turned off, switched off. That will be easier for us to handle this. Thanks. Our agenda today is a first and brief introduction about AR engineers and an overview about the platform. So I will speak briefly about all the different features and areas we have on the toolbox, which is the analytical toolbox, the auto FEA area. Those two features we had as well as webinars, which you can find on our YouTube channel, and where we as well will later on post the webinar of today. And of course, the wiki, which is a very great area to research adhesive joint calculation and adhesive joint applications. And then, of course, we go into detail with the adhesive material card sections on the platform, which will be presented by Fabian. We'll give you an overview about our adhesive products, the application data information, the engineering data that is coming with all the different material data, or all the different material products we have. And finally, we give you an overview about the outlook, what's coming up on calcbond within the next month, upcoming features. And finally, we have 15 minutes question and answers ready for you. All right, cool. So let's get started. As I said, I'm Axel. I'm the owner of AR Engineers. We are on the market for 14 years now. And we are specialized in lightweight engineering, lightweight structures, which is composite applications mainly, and adhesive joints, as you can see today or in our other webinars. We focus on composites, but of course it applies to any other material that can be used for lightweight engineer or lightweight structures. We mainly used FEA for calculation or design purposes. We are working with software as well. We develop software as well, as you can see with calcbond. That happened because we started actually a few years ago to design internal tools for adhesive joint design to be faster with or in projects where we had the challenge to do engineering with adhesives and adhesive joint, and we needed some solutions for that. And with that, when Corona hit us, we needed to, or we thought, well, how can we bring this knowledge and this service to our customers? And we decided to design a software that we can through the web browser bring to our clients so they can do it by themselves and then come back to us if they want to. We are sometimes in the production in terms of manufacturing support or implementation. And of course, we have research and development projects where we advance ourselves for engineering in terms of adhesive joint design and composite. That's from my side. And maybe Fabian want to speak a bit about himself.
Yeah, thank you, Axel. So hi from my side also. I'm Fabian Nowacki. I serve as the head of the engineering team here at the company, and responsible for managing client projects, industry projects in the engineering business, but also R&D projects that we do and have done in the past with different partners throughout Germany, research institutes, and also industrial partners. And as a third area, I am technically responsible for the development of calcbond as a platform, and especially for the adhesive bonding technology topics and adhesive joint calculation topics, which I'll be talking about in more detail later on in this webinar, with a focus on the material cards section today.
Yeah, and if you want to talk to us in a one-on-one meeting, just take that code and send us an email on go on our LinkedIn profile, find us there, and schedule a meeting with us. That would be very straightforward. We can give you an onboarding for the tool, or we can have a chat about lightweight engineering in general. That would be great if you just drop us a line. So one last note: we are working in many different fields and industries. Our main industry is the marine area, where we are mostly in the last 14 years, but automotive or transportation as well are fields where we are located in, or where we are working in the last years a lot. And yeah, 6-7 years ago, we were working in a project to design parts or composite parts for a roller coaster, and that project we actually got exactly that challenge, that we needed to do engineering for adhesive joint design, and we had no in-house tools or in-house methods at hand that we could straight away use to be fast and efficient in that project. And that brought us to the point that we needed to investigate that, and we needed a tool where we could go straight into that and design a adhesive joint and have something where we could research. And that brought us to the fact to design that tool. So and that's what we want to give back to our clients. We want to simplify the use of adhesives, which we didn't have those years, and give methods and a reliable solution for adhesive bonded joints to you, so you can go on that platform and work through that process and have a solution. And that's what calcbond does today. We have 3 main fields where calcbond provides service. The first one is the database for adhesive materials, which we're talking about today. As well, knowledge, where you can go on the wiki and explore the entire field of adhesives, which is of course joint design, but as well material data and so on. There's a lot to research and to investigate. The analytical toolbox, analytical calculation, is something we spoke about in our second webinar, which is roughly 2 months ago. You will find that on our YouTube channel, as I said earlier. The third area is the automated FEA, which you can use as well for calculations. I'll go into that I'll show you that in my little overview on the platform in a minute. All right. So I suggest, no, sorry. Today we speak about adhesive material cards, and about how and why do I need material cards for bonded joints design. The material properties are essential for adhesive joints. That's very, very important. Otherwise, you will not be able to do calculations, stress engineering. And this is why we have a section related only to adhesive material card or adhesive material data. And that's very, very important. We speak about that today. All right, cool. So I'd say let's go on the platform. All right. So first of all, if you enter the platform, I can quickly show you that you're coming on the platform, the landing page on www.calcbond.com, and you go to a 30 days free trial if you haven't done a registration yet, and you go through the process. That's very straightforward. If you started with that or so, you can go on our YouTube channel as well. There's a small 2 minutes YouTube short for you, which explains everything. So there's no excuse for that. And you can go log in if you have an account, and then you go straight on our index page. And on the left-hand side, you have a navigation bar, and top down, you have the analytical toolbox, where you can go straight forward into a use case based on analytical methods, just picking randomly the middle one to show you how it generally looks like. You have the adherent definition, of course, adhesive selection, and the adherent to definition. And further on, you define the single lap joint geometry, and you can go straight away on calculate, and you get your data. As I said, we have a YouTube channel for that, explaining in 20-25 minutes about what you could expect here and how you could use the Design Explorer, where you can explore for example, your adhesive thickness and so on. You can see how your joint behaves in different scenarios. The second tab here is the outer FEA, where we have as well 5 different use cases. In those use cases, you can as well go let's pick one. You can go into that and define the geometry. You can define the material and pick from a list of materials we have, or go to user defined and define your own material if you have something in mind, or pick one of those. The adhesive, of course, we speak about that later on from about this list that we have implemented in each of those use cases. And go into the load case and support area, define everything, and you can straight away go and calculate that. And material cards, I will almost skip that. We speak about that today, of course, as I said. Self-calculation is the same. I think there will be a minute or two where Fabian explains what you could expect here, because that's, of course, important. When you've done a calculation and you have used your material, you probably end up here in that self-calculation area, because there you have all your calculated all your calculated data at hand, and you can go to download your PDF report and see what you have, what input data, what output data you have, your stress report, basically automated, generated on the platform here. Another important point, as I said, is the wiki, and here you can explore adhesive joint design. You can investigate a lot of different information and study about how to design a adhesive joint, how to calculate adhesive joints, and what's important to you if you use adhesives. All right, go back to calcbond itself. And I think that's it so far from my side, and I hand over to Fabian.
Yeah, perfect. Thank you very much, Axel, for the brief introduction about the overall platform. So now, as already mentioned, today we want to dive a little bit deeper into the material cards module, which is one of the main features of calcbond. And that is the section which you can find under material cards on the left-hand navigation bar. And then you will be introduced to a overview section, basically. So it looks like this. We have a table with a set of different adhesive product data sets from different manufacturers that collaborate with us, that provided their basic and also advanced mechanical properties, engineering properties for a range of products. We have Kiesling here on board with the 7490 adhesive to component epoxy. We have Sika with a range of epoxy and also polyurethane and acrylic adhesives. We have Huntsman Advanced Materials with their well-known Aerolite range of products, and also IPS Corporation with their Cygrip brand with the SG300 two-component acrylic, predefined inside the material database that you can use to view and compare data and see which type of adhesive might suit your application in the best way. And if you want to view a single or multiple products, you can click on the checkboxes here at the far right of the table, and this will also be saved if you go through the different manufacturers. You can select up to 5 different products at the same time and be able to compare those in the next step. So let me just quickly choose some different materials. And before comparing, you can also check the main basic data, like application data, like the surface temperature range, the open time, which is also very important for adhesive application, or the basic material properties like the tensile modulus and the tensile strength at room temperature, just as a quick first glance if you want to quickly compare different products. And if you are ready with your selection for the next step, you can click on the green button here at the bottom, view data for selected products, and then you will be sent to the actual material cards. So in this case, we have 5 different products that we want to view, and we can switch in between these products here at the top left side. So we have these tabs here where we can click through all the different materials. So as said, from Kiesling, Sika, also Huntsman and IPS adhesives. And here you will find a set of basic technical data and application data, which is similar to the information that you find in the typical technical data sheets, or also sometimes called product data sheets, that are available publicly usually on the manufacturer homepage. So that is the type of data that you can find here. You have the product name, description, which type of adhesive it is, and also some basic properties where there is some text passages about the typical application cases or use cases that you can work on with this particular adhesive, and a first table with basic engineering data at room temperature usually, and also tested under standard laboratory conditions like mechanical properties, and also some physical properties like the coefficient of thermal expansion, which is very important if you want to calculate at higher or lower temperatures than room temperature. Glass transition temperature values depending on the curing state also, and the density, of course. And further down at the bottom, you will find some additional highlights about product benefits and application areas, which might be interesting if you are looking for a specific industry branch like automotive or rail bonding maybe, or marine applications. So this is all included here. And on the right side is where we work with the more advanced engineering data that is not typically available online and in public, so to speak, but our partners from the different manufacturers have collaborated with us for us to include this data in calcbond and to provide it to you as a user. And here you will find temperature-dependent engineering properties for the bulk adhesive measured through tensile tests, so ISO 527 standardized tensile tests at room temperature, but also at lower and higher temperatures. And here we have this table of the tensile strength, tensile modulus, and the elongation at break, which updates according to your selected operation temperature. So we have these intervals here that are based on actual laboratory tests, where you can see how these properties change with higher or lower temperatures. And also, what is always important to note is that, for example, in this product here, if I go close to or even above the designated glass transition temperature, you'll get a warning so that you can see where your application limit might be for this type of adhesive, because the glass transition is a very critical spot where the properties change drastically, and which can affect the performance and safety of your product. And also for different sets of data, we have typical stress strain curves as average values, representative values, for you to understand how this adhesive performs, if it's more of a brittle and high modulus adhesive with a rather low breaking strain, or if it's a very low modulus but very elastic and high breaking strain adhesive, for example. Yeah, and moving down, we also offer a substrate compatibility matrix. In this example, for the different Sika products, you can see for which typical engineering materials acting as adherents, so as substrates, how are the compatibilities in terms of application of interface, bonding strength. And in this case, we have three different categories. So the green box means basically, yes, this combination fits very well. Of course, you always have to make sure that you perform proper surface preparation. But if you conduct the basic proper surface preparation, you will be good to go with this material combination. In the yellow boxes, this might be critical. So you have very precise and specific conditions that have to be met during the processing and the application in the manufacturing. And the red boxes indicate that you should try to use a different adhesive or a different substrate, because the combination of adhesive and substrate will not perform very well. So this is intended to serve as a guideline for you. So this will, of course, not be the final decision measure for you, but it will serve you as a user, as an adhesive applicant, to quickly understand which types of adhesive products fit well with the different engineering products. So we have different metals here, engineering plastics like PA6, PMMA, PVC, also composites, of course. And yeah, and if you want to further specify the product or your decision on which product to choose for your application, you can then move on from this set of data here in the material cards, and also contact the bespoke contact person that is the representative of the manufacturer directly through this platform here. And also what I can show is just to jump to the calculation module quickly. This will also be shown inside the calculation reports, which we will be speaking about in a different webinar for this calculation feature. But here, if you have calculation reports, you also always get your contact person as a reference inside the PDF document, depending on which type of product you have chosen for the analysis. Okay, and also, which is quite a nice gimmick, if you want to filter out, for example, in the range of Araldite products, you want to filter out adhesives that have a relatively low modulus, you can just quickly type in your filter inside here. And then you'll see, for example, if I want to work with adhesives that have a tensile modulus that's higher than 1,750 megapascals, you could do so by typing inside these filter boxes here, and the table will reduce towards the specific products that are of interest for you with your filtering conditions. Yeah, and to give you a quick understanding of how you can actually work with the data once you know what you want to do for calculation, you can either quickly submit this product to the analytical toolbox by clicking on the screen submit to joint calculation box here, and then you will be transferred to the analytical tool. And for example, if you want to calculate a typical single lap joint, you click on the box. And then as you can see here in the adhesive selection box, this product is already predefined as the adhesive for this type of calculation. And you have the default values at room temperature available here. You can change the thickness, of course, so it will start with a default thickness, but you can change it to whichever value you need. And then, of course, you can also change the adherent materials and continue with your data input for the calculation. And these materials will also be found in the second calculation module inside the Auto FEA feature. You have a drop-down list, as Axel already showed before in the brief introduction. So you have access to all the products that are inside the database of the material card section through the calculation input drop-down, along with some generic products that just serve as a placeholder if you have nothing specific to calculate, but you want to have quick comparison between typically generic values. You can do so also here. All right. And what I would also like to add is if you have some questions about how to work with these values, maybe you are not as familiar or you're not a specialist in terms of adhesive joint calculation, and you know a little bit about mechanics, and you know that tensile modulus and tensile strength and shear strength also are important values, but you want to know a little bit more about how these properties interact in adhesive joints, and especially in the stress calculation, for example, of bonded joints. You can always refer to the wiki, where we have lots of content specifically about the feature, of course. So you can go to the material cards, let's call it tutorial, with a step-by-step guideline on how to work with the feature. But you can also dive deeper into the engineering topics and, for example, go to let's say, result evaluation. So this is more of a calculation specific chapter, but you will learn also a little bit about how to work with the mechanical properties and yeah, how to interpret the results, basically. All right, cool. So that is yeah, the most important information about the Material Cards feature. Of course, if you have some questions right now, maybe feel free to type them into the chat so we can answer them in the Q&A section of this webinar. And to give you a little bit of insight further down the road, we will talk about an outlook on which features are currently in development and coming up soon as new additions to the calcbond features. Okay.
Cool. Thanks, Fabian, for that great introduction. I think that's very straightforward, and the way you can use the materials on calcbond for research purposes or calculation is yeah, very straightforward and very useful. So what's coming next? And that's going into the same direction of how to use materials and material data. And we of course know that lots of clients have maybe their own material test data, even though they use the material that's on the platform already, but they have tests done by themselves to validate the material properties within adherence that they use. And so they will have a different number set or information set. And we work on user-defined material cards, so you can basically come from a material that we have on the platform or even not, and implement that on the platform, so we can use on the platform your own material data set and even share that to your colleagues or to maybe your engineering service, external service that you use, a freelancer or a test office or whatever, and yeah, work from the same database. Another very important point for us is the way how you generate results on the platform. At the moment, that is very straightforward. You will see that on our other YouTube webinars that we have posted on our YouTube channel. That's something where you could do calculation, you get the results, and you have your results set on the platform, and you do your automated reporting, and that's it. And we're working on a 3D result interface for Auto FEA. So this way you will be able to turn your model in all directions, like in a modern CAD model with or FEA model, and see and view your results from all sides. You can rotate that, you can zoom in, zoom out, and so on, and do section cuts to understand your internal and external stresses, and of course do failure criteria and analysis with different result types. So that's very important for us, and we're working on that. That's quite a big step forward. That will not come up maybe next month, but I would say during this year at some stage, we hopefully get this on the platform. Yeah, and of course, that will be implemented into our reporting as well. So there will be a button where you can then transfer your user-defined results from that 3D viewport into your automated reporting. The last thing working on at the moment, one important point is as well that we haven't seen that today, but we've seen that in the webinar for the analytical toolbox. We have a design explorer there for the for 2D problems, and we of course want to have that in our 3D space as well. So one of our motivation to have that 3D viewport is to do a 3D design explorer, and then you could go into your FEA model, use machine learning based techniques to get to your design goal, basically. I have held a presentation about this as well on the CADFM conference a few weeks ago. Just drop us an email. I'm happy to provide that presentation to you, where we trained a bonded stud model to be faster and more efficient to get the design space, and with that design space to be fast to get to the exact design that you want. And therefore, we need to to train that model and then bring that model into the platform, so you can access that machine learning model from your side, from the client side. And this way you can study for a large amount of joint design variation very fast and very straightforward. The response time is, of course, very small instead of the case today, where you go into the auto FEA and do calculation. It takes a few minutes, 5 or 10 minutes. And if the solver is already busy, you might have to wait for, I don't know, half an hour or an hour. And with that machine learning based model, you will always get your results within milliseconds or seconds. And that's what we're working on. And of course, we have a subscription system in the platform. If you go on the platform, you registered, and you go to the to your user area, you will see that table as well. There's a free user. Of course, when you register newly, you have 30 days free trial, as I said in the beginning. So for 30 days, you will have no extra cost. You can use every corner of the platform. After those 30 days, you will be reduced to free users. So there's nothing hidden. There's no hidden trap or something like that. You will reduce to free user, and that's it. And you have to have an action to become a pro, or to stay as a pro, basically, like you had used in the 30 days free trial. So and then you have access to the Auto FEA, to the reporting, and to the Design Explorer. At the moment, we have the spring offer for you. So if you book it now, you send us an email, or you register with the promo code, and you drop us a line that you're very interested in that, you want to book that, and we give you 10 extra tokens for the Auto FEA module that will not that will stay even over the monthly period as well. Whilst you have only 5 tokens every month that will be renewed every month, but they don't add up. So every month you've again 5 tokens, and those 10 tokens stay over those month period. So 3,000 euros for that, including 10 extra Auto FEA tokens. All right, I think that's it. If you are interested, send us an email, drop us a line, or scan that code and book a meeting straight away.
Yeah, so thanks very much for listening so far. And I hope you were able to learn a little bit more about calcbond and the material cards features. And feel free to write down your questions about anything about calcbond into the Zoom chat, and we'll read it out and try to answer it as best as we can. And if you have nothing on your mind right now, maybe something comes up later on, you can always write us an email. We'll be happy to answer it then afterwards. So maybe in the meantime, we can also already make an announcement for the next webinar. So the next calcbond webinar is currently scheduled for the end of June, so in approximately 2 months, on Thursday, the 27th, again at 4 p.m. Berlin time, so Central European time. And make sure to follow us on LinkedIn and also on YouTube. As mentioned, we have the calcbond YouTube channel where you can find the previous recordings of the webinars of February and the times before. And also this webinar here today is recorded and will be uploaded to the YouTube channel shortly in the next days. So if you have maybe missed something earlier on, you can also always rewatch it, and follow us on LinkedIn to be up to date with platform updates, event updates about webinars. So the next webinar will be promoted and announced through the LinkedIn channel and via email newsletters also. All right.
Yeah, thanks a lot from my side as well. And great to have you here, to have had you here on the webinar, and I'm looking forward to see you again on our next webinar in about 2 months.
Yes, thank you very much, and see you and talk to you soon.
Bye-bye.